Yes. Okay, so I got my slide. Yes. So you can find me on GitHub, on Twitter. If you are interested, find me after the presentation. I will be happy to answer all these questions that you might have. And if you got any questions within, like, at any point during the presentation, just ask. I really like interaction with the public. So yeah. And I'm, as I said, I'm a Scala developer. For over 7 years, I'm working with Scala for around 4. I'm involved with the Scala community in Kraków. And for like 5 months, maybe 6 right now, I'm involved with Kotlin. And my day job is confidential. Of course, I'm joking. This is back in my slide. I'm creating a tooling for developers. So we got a project where we got like over 500 developers. They all contribute to the same branch in a single repository. So it's like 50, 60 pull requests per day. This is a Scala code, so compilation is terrible. If you think that your compilation is slow, I will double that and double that and double that. And as for Kotlin, so why Kotlin? Because due to my tooling experience, I start managing some Kotlin teams. And for now, we're developing Eclipse Kotlin plugin. Yes, you can develop Kotlin on Eclipse if you like to. And we also started quite recently trying to make Docker usable again. Do you know what Docker is? Is there like anyone that knows what Docker is? Did you ever seen like fancy documentation from Kotlin? The Docker is the tool that creates the documentations. It was a bit rusty. Now we're like scraping the rust off of that, and I hope it will be like shine again soon. And I also, as was mentioned, I'm organizer. Right now, I stepped down a bit from Scala because I don't have that much time from Scala, and I got like really nice colleagues that are doing Scala for us. And I'm also organizer of the Sphere IT conference. And there was a mention of the lottery. There will be one more lottery because at the end of the talk, we got 1 free ticket for the conference, and more on that later. So I'm from Virtus Lab, and there is a plenty of logotypes. I hope that you recognize few. So we are the company from Kraków, and we try to support as many communities as possible. So right now we just started TypeSafe meetup. I think it will start next month. So we will have like 3 or 4 meetups in Kraków, meetups in Rzeszów and Kielce. Not yet in Warsaw, but we would love to help the Kotlin community in Warsaw. So I'm really, really glad that we got this meetup, this event here, and I can speak to you. Maybe I'm not like the best Scala, I'm not the best Scala by any means. Also, I'm not the best Kotlin speaker, but I love to see this kind of audience with this one place learning about Kotlin. I think we can make it going, and we can be big. And yes, I mentioned Sphere IT. You can see Sphere IT here. So Sphere IT, so the conference that you can win a ticket after at the end of this talk, is a conference that will take place in the October in Kraków. And this is not dedicated to any specific languages. We got the spheres that covers topics rather than languages or technologies, like reactive programming, not programming with React, but reactive as a whole concept. So everything starting from like Java Rex up to fancy stuff done, like I think Kotlin coroutines will fit there as well. Data science, JavaScript, more or less, but it's not like all JavaScript, but like working on maintainable JavaScript and cloud native, like so Amazon, AWS, or like managing Docker stuff or anything else that can fit in that topic. And this is just a brief of that, because we'll have also Kotlin as well, not as a main event, but as a part of the side event. But we will have event like that during the Scala sphere, and I'm pretty sure among few of that spheres there will be like Kotlin talks. So yeah, there is a chance to win the ticket here. Again, slides, there will be like, please do not take the pictures, because this is the old link to the old slides. The code base is fine, but the slides are old. So there are not much of the slides, but I will tweet it after the presentation. So we will get that. And with that brief introduction, we can go to the main topic. So does Kotlin slow down our code? This is the question, like, I remember that during my university times, whenever I said that I'm gonna do something in Java, because Java back then was this fancy language, and everybody was telling me it was slow. And in the beginning there was like I was stranger than everyone else, because most people that start the first year, they learn how to program in C++. There is this Symphonia C++, everyone reads that. No, I start from Bruce-Eckel and thinking in Java. So this was my first programming book. And there was a competition on one of the lectures. And so there was like an algorithmic problem, you have to solve it, and like whoever is the fastest, there's like we were like, exempt from exams. And the problem was that I really wrote a code in Java and I did not send it because I thought it was slow. It turns out like no one solves the problem and my algorithm works. So I was just scary because it's slow, because I written like a slow language, so it will be slow. So I want to answer the question like whether Kotlin is slow. So whether you should like, ditch Kotlin because it's slow. We all love Kotlin, but the question is why? I asked this question many times during interviews for Kotlin positions, and things that amused me that no one has any kind of problem answering this kind of questions. I got like multiple reasons, and I usually was forced to actually stop the candidate for doing why he loved Kotlin or why she loved Kotlin, because there's like too many things. So why do you like Kotlin? Maybe cool. I've heard in the beginning, I said one thing. There was a thing about the property delegation. Anything else?
Coroutines.
Coroutines, yes, coroutines are awesome.
Composition by delegation.
Composition by delegation. But I heard that they plan to actually remove that from language.
Yeah, I think the same as companion object, they don't like that.
Companion objects are also cool.
But they don't like that.
Yeah. Maybe back of the room.
Null safety.
Null safety, yes, null safety.
Extension functions.
Yes, whole inline functions. Do you know about inline functions?
Sure.
They are awesome, but this is my thing. Yeah, so to be honest, I learned Kotlin like a few months ago, and I learned Kotlin, like I decided I will give this presentation before I started learning Kotlin. So I have no idea what Kotlin is more or less, and I started actually learning Kotlin. And the idea behind that was actually to get all this nice stuff and compare that with what I know from different languages, and also learn Kotlin thinking, what is slow in Kotlin? What might be slow in Kotlin? Because I got some knowledge of JVM. I used to, like, one of my projects was actually generating Java bytecodes. I tried to profile and optimize various stuff. I usually failed at that because I'm not smart enough to do pretty deep optimization. Yes?
There should be inline modifier now.
Yes, inline modifier.
They're lambdas.
Okay, maybe it is old. Sorry, good point. I will fix that. There is more. So during this presentation, I want to take a few because if I really want to go deep into like complicated stuff like coroutines, I wish I have time to actually learn more about like how coroutines are so nice and how they are implemented over the bytecode. But I think after 5 minutes, everyone will be bored. So I will try to do a few simple things, and I will try to show you if Kotlin is slow or not. And I hope you will get a good picture after that, why we should not answer that question, is Kotlin slow or not. So null safety, we all love null safety. We got in Scala this nice optional from Java. And to be honest, they're mostly like in Java world. They're mostly used to wrap around nulls. And I think the creator of Kotlin said that nulls are fine. I even see like they are arguing with guys from like Scala or Java community saying, nulls are fine, nulls are fast, nulls are good, but you have to control them in the type system. And I agree, and Kotlin, I think, did it right. But there might be a cost. There might be a runtime cost because I'm concerned about runtime cost. Because, okay, I can live with the slow compilation. Kotlin compiles like twice slower than Java. Maybe not, maybe 3. Scala compiles like 20 times slower. So for me, it's like Kotlin is super fast to compile. So with that in mind, let's jump into null safety. But before we go, there is one other aspect, because we really have to distinguish between, there's like 3 groups of features. There are features that are like, syntactic sugars. So it basically lives only in the compile time, and there are features that actually map one-to-one to Java. Of course, and I forgot to mention, sorry. Everything you will learn here and listen here is about the Java as a JVM bytecode. So I'm not expert by any means on Android. I plan to actually run some stuff on Android or native or even JavaScript. But I decided then if there is a question about something, I will say I have no idea. So I'm sticking here to JVM. And I hope at some point every one of you will touch JVM or is already touching JVM. So yeah, so coming back to my thought about the 3 kind of concepts. So first one is like mapping one-to-one to the underlying language, like JVM or Java. The second one is stuff that are a little bit better. So for example, think about data classes. So this is something that can be like right in Java, but Kotlin do is for us. And there might be some overhead in terms of runtime, but we don't know that. Maybe there is, maybe there is not. And null safety is one of this kind of stuff. And there's a third group that is mostly interesting for me, is the kind of features that are not present in JVM, like lambdas. Lambdas used to be before, but like objects, for example, or inline functions. There's nothing like that in JVM. So how does it, like, is it slow, fast? How well it works with the Kotlin? So with that in mind, let's look at null safety. So we need to measure stuff. So we need to write the benchmarks. Can you see the font, or is like way too small? It's okay, cool. I love presentation mode in IntelliJ. It's like one of the best features in there. So we got pretty simple program that do Java, do Kotlin, run a function in Kotlin and Java, and like compare times. So what the function in question is, in Kotlin, basically this is a stupid function. But yeah, I want to do something, so, and I want to check pattern matching. How cool is that? So yeah. I'm trying to write some kind of generic function to get compute size, because let's say I got a collection from literally all APIs that doesn't have any kind of type information in there. So I need to pattern match against type. And basically, if I got a string, I got length. If I got collection, I got the size as 0. I should throw an exception, but yeah, this is just to show whether the null safety is there. And as you can see, this is a code that is called, because my benchmark later on will be in Java. The original one is in Kotlin, but and it doesn't have a question mark. So Kotlin, when you call that with Java, it has to ensure that there is no null passed. And this is kind of runtime aspect I'm interested with. And there is also a safe side. When I add the question mark, I really love that it's also handled by when, so I don't have to do anything. And smart cast, amazing stuff. Really simple. I don't know why the other languages does not have that. It's like, yeah, cool. And I got Java. And in Java, the same code, ugly. And yeah, and of course, I'm not safe against null. So if there is a null, I'm screwed. So let's run this, shall we? Oh, do you see the numbers here? Kotlin is really slow. End of presentation, we should not use Kotlin. It's like 3 times slower. Let's run it again. Yeah, still the same, but the numbers changed. It like quite a bit. So maybe the benchmark is lying to us. So let's be clever. Okay, maybe it's because like the Scala of one method is like so small, so the time is not right. That's actually true. So let's run it multiple times. So let's pick like a lot of times here, and we are doing a loop, and yeah, we will see whether the times for Kotlin are better or not. And still the time is like less than 4 times, but it's still slow. I think we can do more. So let's twice the amount of loops, of iterations that we are doing. We can, I mean, this is super fast. And still there is like 3 times, but did you notice that the Java time like behaves strangely? So let's twice it again. So let's remember, there is like 2 milliseconds to run everything from Java. Roughly like 2 milliseconds something. So right now it should be like around 4. But it's 3. Something is not doing right, so let's add more. Now it's probably too many. But the numbers are not quite working as we should expect. I mean, right now Kotlin is almost as fast as Java, and previously it was like 3 times slower. So are we doing anything wrong? Yes! This kind of benchmarks are not benchmarks. Because in Java, over JVM, sorry, there is something called just-in-time compilation. So basically Java JVM is smarter than anyone else and try to optimize code on the fly. This is really fun because on JVM, like when I was producing bytecode, I would try to read articles how to write fast bytecode. So whether I should use like this kind of operations or this kind of operation. And you know what is the clue? The only clue that they give you to write the fast bytecode if you are developing language? Write the same code as Java does. It is optimized for that. It will be fast. Don't worry. And it is. So then how we can measure stuff? Because, okay, I'm a library author. I want to run, or I want to benchmark my code if it's fast or not. Or, yeah, like I'm like super crazy about performance of something. How can I measure that? You are covered. Java community is like 20 years old or something. And there is a library for you. It's called JMH. So let's come to first actual benchmark. So we got benchmark in Java, so plenty of annotations, like plenty, like almost more annotations than the code. I'm really glad there is no XMLs. I have to configure for that. But the library is really cool. So there is some options here, not interesting. The only thing that matters right now is the throughput mode. So it means just to know what the numbers are. So basically JMH is doing what I did before. So running stuff multiple times under the hood in the loop and then count it and then measure the time. Because actually time, there's like you got nanoseconds if you want to compare, but no computer right now can actually give you precise amount of nanoseconds. The resolution there is like 20, 50, sometimes 100 nanoseconds, and it's quite random. So there is no good thing to measure stuff. And throughput mode means that it counts operation in given time unit. So basically, the more like the number is higher, the better for the, so it's the code is faster. And we got something here that is called black hole that counters what was happening before. Like the numbers were so strange, mostly because Java realized that the previous loops was pointless. We didn't do anything here. The results of the, like, I cannot see the difference except for time, and I want to optimize the time, so I can cut it off. And black hole saying to the JIT is like, you have to do that. You have to compute that value because I care. And the implementation here is nasty. I don't want to say it, because it probably will hurt my eyes and probably is manually written bytecode. They got quite a lot of problems whenever a new JVM show up. They have to benchmark their benchmarks, whether they're like slow enough, crazy stuff. And yeah, so I got 2 benchmarks. So after that, after I got black hole and benchmark notation, this is a plain code in your favorite language. Benchmarks from Kotlin works. I got 1 more. Benchmarks from Scala works as well. But I'm using Java, just to be, because in most cases, in one case, I have to use Kotlin. I will show you why. Yeah, but I want to get the results. So we got Java, Kotlin, and into flavors. So Kotlin with not null annotation and Kotlin with null label annotations. So the only difference is that one of that methods got this question mark. I showed that before. So shall you run benchmarks? I can show you how to run these benchmarks, but I don't want to. This machine is not perfect for benchmarks. I mean, look how small it is. And basically, if I will be like breathing closer to this, the CPU will be hotter and the result will be worse. So I ran it on like quite stable, but not as stable as I wanted machine in my home. And I got the results for you. And also, sometimes results are not as predictable as you want to. So you don't want to screw your presentation just because you, for example, there is something going on, like your OS trying to check whether there is an, like you have to update the software or something and kills your benchmarks. So this is the output. Of course, the output is much longer if you run the JMH, but this is something that so we can read and know what's going on. So we got Java, Kotlin, node nulls, and 2 flavors of Kotlins. And as you can see, there we got the results here. So pretty much equals, and especially if you look at the error, because even if you do this JMH magic and you're doing like running really small stuff well prepared, because it takes you sometimes to actually get to stable numbers, there is this error. Right here is not bad because it's around like 1%, so I'm quite happy with that. And the result is pretty much that maybe Java is a bit faster, but yeah, it's pretty much, the difference is so small that you should not care. Why is that? I can show you the bytecode. Are you ready to see Java bytecode? This nasty stuff? I can show you bytecode. So, sorry, not this one. This is not a bytecode, this is Java. I know it's hard to tell the difference, but I hate typing on the screen, but I have to do this just for you. It always goes wrong. Yes! And I even mark it, the place that is interesting to me. As you can see here, the bytecode is not that bad. It's actually, you know what is crazy about the Java bytecode? It's type safe. So Java is like, you don't have to cast stuff. It's type safe and JVM checks and Java compilers checks whether the bytecode's compiled is fine. So it's actually quite easy to write bytecode. If you see what crazy Java, like Java code before Java 5, the bytecode is not much different than that code. If you got like casting everywhere and you know what's going on, bytecode is nice. And in the beginning, as you can hear, this is this strange call to Kotlin JVM internal intricts check parameter is not null. So this is the thing that I was worried about. And it was gone. There is no difference. Why? Because checking null is super quick. There is like reference to the null is fixed one, so it's basically comparing two integers. And I think JIT, when it decided that okay, there is no nulls going on here, I can just cut off this code, or even inline itself in the method. So basically, that is why there is no difference. Even though in the bytecode there is a difference. That is why JIT is amazing. Okay, but I'm still not sure. I mean, the result was too good. And previously, like I wrote the benchmarks and it lies to me. And I said that I spent quite a lot of time actually writing those benchmarks. So are those benchmarks right? Let's prove that. I mean, it's hard to prove it. You know, I cannot like write a mathematical thesis like describing why it's fine. I mean, there's another way. There's a technique that is called, you can basically create a baseline. So what is baseline? Our benchmark, there is, except for the things that we want to test. So for example, like there is a base length, there is the size method that we are calling, there is looping over, there is like accessing a object, and it takes time, but it's not the thing that we want to measure. But without those things, we are unable to write the benchmark. So the idea here is we're writing a Java code that is basically doing similar thing as we want to do, but without the operation that we are interested in. And it is usually, this can be used like in two ways. So it can be used just to compare. So when I'm running benchmarks on different conditions. And when I was actually, we try to benchmark and we try to optimize Scala compiler, and the best resolution for the compilation was 5%. So there, even of the like super stable machine with super stable condition, the like two sequential results was like 5% difference. So basically every kind of optimization below 5% was like, we were not able to prove that there is an optimization. And that is why we try to think about baseline. So we got a baseline and compare like not the actual numbers, but trying to compare like a ratio of the time, but it also doesn't work. But you can do this sometimes. But also baselines are quite good to prove that the numbers are like, make some sense. So yeah, let's show. So what I got here is I'm consuming simple operation length. Then I'm like just calling some methods here. And for Kotlin, I got the same thing with basic length, just to be sure. And so what are the results? As follows. As you can see, in both Java and Kotlin, the numbers are growing steadily up. Which means this is kind of proof that the result is quite good, because we are doing more operations, so they are taking like more time. Did I convince you that my benchmarks are correct? Who is not convinced? I'm not convinced, so. But yeah, benchmark at some point is always like some kind of guessing, especially if you don't have your environment is not predictable, and JIT is not predictable because it's the heuristic, so yeah. Okay, so we are past null safety. So null safety is fast. Good, let's go further. And here is like, we got properties. I don't know if we'll dig into that, but we got data classes. And I don't know if I want to go into the details. Do you want to see bytecode of data class from Kotlin? No, we don't want to. So I just show you the numbers.
Can we see Java? How would they look in Java?
I can show you how would they look in bytecode, because I don't want to do it live to actually transfer bytecode into. I'm sorry, wrong file. Into the Java code, but look at the bytecode. This is a POJO, so like fields with two setter and getter on two fields, and one static method. And this is from Java, and there is the same thing from Kotlin from data class. So basically, the bytecode is pretty much the same. What is added is just few methods, so it's basically just runtime generation. And the only difference is there is like this null checks again. But we know that there is no much overhead with that. So good. And I'm just so we don't like say I'm cheating here. I will show you the results. You may notice that I got like two results from two JVMs. I got results from JVM 11 and JVM 8. I will mostly show you the results from JVM 11 because it's the latest one. But we might see also the difference from JVM 8 in some features. So yeah, as you can see, the Java is maybe slightly faster, but the change is pretty much meaningless. I think at some point there is a check in JIT that okay, that thing is not used about the null checking. Okay, it's not. So that is why it introduced like this tiny pig in performance. But yeah, it's nothing. Okay. So we got properties and data classes covered, more or less. And now let's go to something that is really interesting: extension method and objects. So, are you using extension methods? Are you writing your own extension methods?
Yes.
Is there anyone here that doesn't like extension methods? Me too, I love extension methods. And I wish, because in Scala they introduced something called implicit that is nasty, and I wish they start with extension methods because they're like so nice, so clean, and so good. I mean, yeah. And objects, I love objects. Do you like objects? I can see your point. Because with extension methods, there's little point of.
We like in Android to use dependency injection, so like objects are not very popular. So we have like cycle objects in this thing.
And I think Kotlin is like stole a lot of sense for objects so you can actually define the methods on top level. So objects are not here there to use to solve the problem with storing the methods.
But they are not synchronized, aren't they?
Objects?
They're all lazy and synchronized.
Yeah,
They're
but
guaranteed like this.
if they are containing some state,
You should not put state in your object. Like the biggest problem with any application, if you put a state, especially that can be like missynchronized in your object. Unless you really know what you are doing and you are guarding against that. Because sometimes you need like, single point of something. Or you have to work with a framework that requires that. So let me show you the extension method benchmark. And this is the only benchmark I was forced to write in Kotlin because I really want to benchmark the usage of the extension method. And I cannot do that in Java because Java doesn't have the extension method. So I wrote a benchmark in Kotlin. It's due to the fact that you need to put this crazy amount of annotation, open class, and this is not like Kotlin-like code. It looks like Java, but yeah. If you're working with Java framework, sometimes there is no other option. So we got three things that we are doing here. So first, as our, let's say, baseline to compare stuff, we doing like this simple method. The idea is here that we like passing a login from user, and based on that, we update our POJO with name and age. Of course, I should write like some kind of regex that parsing the number, assuming that this is a year of born of like beer but yeah, I didn't want to like make it too long. And we got the same code with two kind of flavor. So the first one is extension method. I mean, I so love, and the piece here that I don't have to specify this or like any kind of instance, but it feels like I'm within that object. That's amazing. Yeah, sorry, I have to say that. And there is also a method from the companion object. So basically, both extension method and companion object is not something that is defined by JVM or Java. So it has to be somehow implemented over. And this is the first thing that we need to see that is new, completely new. So do you want to start with bytecode or benchmarks? Let's start with benchmarks. Bytecode is harder. So results. And these benchmarks are quite boring. Every time I got the same numbers. Kotlin, what are you doing to me? Why are you so fast? Why are you so fast? Yeah, and so let me explain that. Basically, I'm quite surprised that companion object is so fast because the extension method is basically under the hood just a static method. So there is no magic here. It's just written like smartly by the Kotlin compiler, and it analyzes the code within your method, and every time there is like you are referencing like a value or method from the object that you want to extend, it just adds the call on the bytecode. So it's simple. But companion object is quite different. You might think that method in the companion object is just a static method. It is not. There is a static instance that is initialized once. So every time you call that method, you basically get an instance on the stack, get that instance on the stack, and call a normal method on that. And why is that? Because you want to, for example, have a disk of object. There must be a disk of object that you want to access. Object needs to have a hash code, for example. So yeah, that's why it's implemented, but GD is smart. It's optimized pretty much. I think under the hood it was rewritten to the same code because GD realized, okay, this is something they're doing, and yeah. And Scala is using the same approach as Kotlin for like many years. And JVM developers that works on the JVM, they realized that around 6 or around JVM 6, I think Java 6, that it's not only the Java. So basically there's like many other languages that using JVM as a platform, so they take their needs into account. That is why they introduced in Java 7 the invoke dynamic. That actually changed Java right now. So every brand new nice feature in Java is because of invoke dynamic. And the sad part is that Kotlin does not take advantage of that. Because Kotlin is stick to Java 6, so it can work with Android. Invoke dynamic is not used in Kotlin Lambdas. Yes, I got this. Yes, Lambdas are the next step on our roadmap. So it used to be like, if I given this presentation like 5-6 years ago, I would say that Lambdas are something new on JVM. But right now they are not, and yeah, thanks heaven for that. So let's see on Lambdas. I got 3 things here, more or less. So the first one is Lambdas. You're all using Lambdas all the time. But do you know what closure is? I know that you know. Let me explain. And let's go to Kotlin code for that. So we got a method from written like static method in, sorry, wrong one. We got static method in Java that accepts function and basically doing some random thing with that function, basically calling that function 3 times. And here there's the difference between method pass lambda and pass closure is that we're using this prefix here. So in pass lambda, this lambda is static. It does not depend on anything outside of this context. So basically it uses just n as a parameter and doing stuff on that. But with closure, as you can see here, there is a prefix. And we are using that prefix here. So different calls to method pass closure needs to have a different lambda because this different lambda have to access different prefixes. And if you know Java, there is if you're creating anonymous class within like a function, then you have to make everything that is within that class as final, just because of that. Because anonymous class is basically a closure over some state within that function. So why I changed why I testing both lambdas and closures? Just because Kotlin do something really strange stuff with the closures, with lambdas, because the lambdas there is only one instance of lambda. So it's cached. And we are running out of time, more or less, so I have to be really quick. So I will show you first at 8, JVM 8, and no difference. And now, when we go to JVM 11, sadly, there is a bit difference with so the Kotlin closures are a bit slower. But what is really good, what is really amazing, I hope that you can see how much the numbers grew. And it was the same code right on the different JVM. So basically Oracle and everyone involved in OpenJDK did amazing job in optimizing lambdas. So lambdas are fast. And I think we will skip that part. This is the part when I really want to make Kotlin slower. Finally, like super slow than Java, and I failed. Now you know. And the last thing is the last thing is the lazy. Because I want to show you, because okay, we can say that Kotlin is fast, but I said that GD is nice. But are there other languages that doing the same thing over JVM are wrong one, are also as fast? So I got the benchmark here. So I got the benchmark when I want to try lazy. So I got lazy from Kotlin. Nice property delegation, lazy, cool, really nice abstraction. I got Java, where there is no such thing, so I have to improvise, so I just write the getter with checking of nulls. Ugly, you should not do this that way, but this is something I can throw on the screen quickly. And behold, I've got Scala here as well. Almost as nice as Kotlin, but lazy is built it's like part of a language, so I cannot like write my own lazy. And the results? Sorry. Scala is the slowest one. And of course, Java is way faster. And this proves that Kotlin did a really good job. I'm always impressed how much effort the Kotlin team invest in the writing optimized bytecode. Because I don't have much time to show you, but I also benchmark simple use case of inline classes. Because like Lambdas or closures, especially closures are slower, but with inlining, it's as fast as in Java. And that like inlining is an amazing piece of work. So they got really because for example in Scala they think, okay, libraries will do everything and we do something simple in our compiler, focus on the type. In Kotlin they go the other way, like coroutines. This is like enormous piece of work actually rewriting code so it fits. And this is the place where Kotlin shines. And as you can see in that simple case of lazy, where it's like configurable and nice, it's faster than Scala. It's slower than Java. Why it's slower than Java? Because Kotlin got, yes.
Synchronization.
Yes, synchronization.
And well-established synchronization, but you can turn it off if you change a lazy mode to different,
Yes. So I got, as you can see, there is 3 options. The first one is synchronized, that is by default. There is also none and publication. You know a lot about Kotlin. Which one will be the fastest one and which one will be like the middle one?
None should be the fastest.
Yes, at the middle one, because I want some synchronization, but I want to be fast.
Publication is fine, but the default one is the slowest because it's a proper synchronization.
Okay, so if you want to write like fast code that is also safe, you will just switch the default mode into publication. You say that.
I would use default, I think, but okay.
But yeah, but if this is a problem,
Properly.
let me show you the benchmark. So as you can see here, there is little difference, but publication sync that should be faster. And the only reason why we can like switch it to publication sync is to make it faster. It makes it slower, tiny bit, but it made it slower. So this comes to my final thought. Do not think about performance when you write the code. This is the thing that you only cover when you got a problem. Because after I benchmark compiler for a while, I will start thinking about performance. And after 2 weeks, I realized I was super slow in delivering the code. The code was worse. Why? Because I was constantly thinking, is this fast or not? And this actually killed my productivity, make my code ugly, and in most cases, probably make my code also slower. Because the proper way to write fast code is write code that works and then try to benchmark it, maybe benchmark it, but try to profile it live. Because Pareto rule in the terms of optimization is sometimes like 5% of the code cause most of the problems. And have you ever got the problems with performance in your application? You are lucky. But in most cases, the problem is either I/O, database, or the problem is within the algorithm. Or the problem is like that you wrote the code wrongly. And I've talked when I was preparing to this presentation, I, for example, talked with Jarek Pałka. You might know him, and like ask him about this kind of question. And he said every time there is a problem with like configuration of something, there is a problem that someone is using like completely stupid algorithm or allocation. Allocation is performance killer. So that's the end. Do you have any questions?